Sorry I'm running behind. I was sending out a remind message. You should be getting on your phone right about now if you're watching this, at the same time. Basically what I was saying is this week's test, Danny wants back the next day after you get it. I know I had told some people 2 weeks because that's our normal process, but whenever I asked Danny about it, he was like, they have a test on the last day? Well, I need that grade right now. So that's what we decided, was just, if you pick it up on Tuesday, bring it back sometime Wednesday. You don't need to take off work. You just need to drop it off in the mail slot. If you pick it up Wednesday, drop it off Thursday. If you pick it up Thursday, drop it off on Friday. And then we can be done with this year. Next week I'll be grading your test from next week. I've graded most of last week's tests for the two of you that are watching, or the ones that will be watching this. Almost every single one of them that I graded was 100. Or I say last week's. I graded AC Theory Level 2. And they're basically all 100. I haven't gotten to all the classes, every test. I have 10 tests left to grade. But I'm fairly confident those will be in the 90s. So congratulations on that, most of you. So yeah, thank you for paying attention. Okay, so let's get started on this. So this question number 1, we have how much voltage is dropped across R1 in the figure below if the total current is 4 amps. So let's zoom in. That got a little bit bigger. Okay, so if the total current is 4 amps, well, that means the total current flows through the source, goes through R4, it splits between 2 and 3, and the total current goes through R1. They're asking what the voltage drop across R1 is. So we have a total current of 4, and a resistance of R1 is 8. So all you have to do is multiply those two together, because we have current and resistance, and we're looking for the voltage on R1. That's all they're asking about. So that's going to give us 32 volts. All right, moving right along. So vector 1, that is this vector right here, it has its initial point, which is this spot right here, and terminal point, which, I didn't fully read this question. That's my bad. We're just going to talk about initial point, because I didn't put answer options for the terminal point. Oops. Okay, so V1 has its initial point. So, like I said in the last video, going this way is negative. So you do X first. 1, 2, 3, 4. So that's going to be -4 to get to there. And then it's 1, 2. So it's -4, 2. Good. Most of y'all worked out that I didn't put 2 spots. I'll have to update this test whenever we get done going over this. A vector is a measurement that indicates both magnitude and direction. It just started coming down outside. All right. Indicates both magnitude and direction. Next up, what is the instantaneous value of a 24 amp peak AC current at 60 degrees of rotation? Given sine of 60 degrees is 0.866. Oh, I didn't put an explanation. So, Oh, so we might be having a few issues right now. So just bear with me. It looks like our internet is being a little bit choppy. And that's on my end. What is the instantaneous value? So if it's a 24 amp peak, you're just going to take the peak times the sine of the current degree. So it'll be 24 times 0.866, and that gives you 20.8. And then finally, a purely inductive circuit will result in a lagging power factor. So Eli the Iceman, let's open this up. So a purely inductive circuit will be Eli. Voltage, or I guess it might be easier to see E-L-I. And then current. So, and Elm is for inductive, so you know which one is which. So voltage is ahead of current. That will give us a lagging power factor, meaning the current is lagging the voltage. A purely capacitive circuit will give us a leading power factor. That is where, well, let me just select. Current is leading voltage. So Eli, in an inductive circuit, you'll have a lagging power factor. In a capacitive circuit, you'll have a leading power factor. Okay, and that is it. So thank you guys. Message me with any questions you have, and I will get right on that and answer for you. All right, thank you so much.